I built an AI research assistant to draft out scientific research papers on any topic you want. And in this video, I'm going to show you how I built that using LangGraph. I actually already talked about this system in a previous video, but in this one, I'm going deeper into the LangGraph implementation at a lower level. In addition to seeing the actual Python library that I wrote for this, we're also going to be looking at a Jupyter notebook so we can explore LangGraph in a little bit more depth. Now, from a scientific point of view, the results that I'm getting out of this are laughable at best. They're actually probably pretty offensive to researchers. So I want to stress that the results are not the point of this. The point was to demonstrate how to use LangGraph with a practical use case. And honestly, the results were cool enough that I was excited to share what I've built with everybody, and it could be a starting point of something a lot better. So before I show you the code, I want to quickly demonstrate the tool, and you can get this code on GitHub. There's a link in the description. Go on into this folder, AI Scientific Research Agent, and you'll see my library right here. So we're going to run python-m sci research agent, and I've got my virtual environment installed and activated already. This is what our agent looks like. This is a little graph for it, and we have access to these tools, and this is the whole point of an agent. So it starts talking to us, and we're going to try and find a topic to research. I already have a topic in mind, and I'm going to say neutron stars. And okay, so that has triggered the agent to do a tool call to arXiv, and I'm using the arXiv API in order to get research papers about neutron stars. So it's gone ahead and grabbed those papers, and now it's provided that as context back to my LLM, which is Claude. And so now Claude has taken all that context, and it's sort of output that in a nice way for me. So there's some topics that I could maybe look a little bit more into. So this first paper looks really cool. So I'm just going to type 1. And in order to look closer at that. And so this triggers my agent to download that paper. So now it's grabbed that PDF, and it's just outputting all the contents as best that it could interpret it using a Python library just to read that PDF. So this is another tool call for my agent, and that has been provided. This context now was provided back to Claude again, and it's saying, okay, here's a summary of the paper. These are the authors, the abstract, the key findings, and so on. And now it's giving me ideas for future research. Often papers will talk about ideas for future research in the summary, but I've prompted the model to basically figure this out for me. Let's look at these. What can we do? Simulations of instability. Develop numerical simulations. Okay, let's again go with the first idea, this model complexity. So I'm just going to say model complexity, and we'll see what it does now. By the way, I wanted to open up another window down here. Okay, so I can hop down here, and what I can do is I can look at the logs. So I have this logging for us, and the logs can be interesting to see what's actually happening. For example, here I've logged an HTTP request being made. So the result of this HTTP request is up here. So we'll come back up and say, okay, great choice. Let's do model complexity. It gives me a proposed research direction. This is based on this direction. I can help craft a detailed research paper. And I say, yes, write this paper for me. Let's hop back and see what's going on down here. So it has received, yes, write this paper for me, and we're going to see what it does with that. So we've triggered a tool call to render a LaTeX PDF. This is the final tool being demonstrated from our agent. So yes, write this paper for me. That triggered a post request to Claude's API. Then we're seeing that we wrote this text file, and now we're compiling that to a PDF. We've successfully generated that PDF. After generating it, there's been another HTTP request to Claude. So basically the agent is going ahead and doing all of this work without us needing to prompt it explicitly, because I've given it access to these tools. So it went ahead and drafted a paper and then rendered that as a PDF. And then it just sort of tells me, okay, here's your PDF. Like, I've gone ahead and done that work for you. You can go ahead and download it. And so this is the link right here. I could copy that, but we're going to see that. So I have a new window, and this is my little outputs directory. It's just in the output folder. And so it's gone ahead and created a whole bunch of files in here, but we care about the PDF. So let's go ahead and open that, and we'll see what it looks like. So this is the paper that it's just written for us. At a glance, it looks pretty legit, but it's pretty short, and obviously everything it's writing is not necessarily new research. It all just looks legit. Anyway, this is what I built. And of course, you could go ahead and actually open up this text file too. So if for some reason this outputs something interesting for us, we could just simply like continue building it out based on this this sort of outline that it's written for us. Thanks. All right, so so that's what I've built, and now I want to talk about how this works in a little bit more detail. So I'm gonna hop back over to our code, and we'll just like quickly look at it in Vim. I talked through this workflow a lot more detail in the last video, so here I'm just going to show you just for a few seconds how this works. We're using this OpenAI model. Actually, I lied when I said Claude. We're using OpenAI for this, but I could simply use Claude just by commenting that line in. But in any case, so then if I come down, we are creating a React agent. So this stands for reason and then act. And they sort of have this pre-built for us. And I talked about this again in the first video in more detail, so you can check that out if you're interested in seeing this and looking at a bit of the source for that, some of the source code. But with this one line, we create our whole graph, and then I'm just simply calling that. So if I come down, I have an initial prompt that I sort of put as the initial condition, and then we start our chatbot, which iterates in this like infinite loop of talking with it. And the interface for that is graph.stream. And the last thing I'll show you is the initial prompt. So here it is, and this is kind of the brains of the agent. This is what I've written that sort of tells it how to act, and I have no other like baked in instruction for it. The reason it's using all these tools is because I've told it about the tools. So we provide the tools down here to the React agent. That's it. So what we're going to do now is switch to workflow number 2, and this will let us talk about LangChain at a lower level. So if I go over to my main file, this is my entry point for my application. And here I'm going to switch the workflow to workflow number 2. So everything works the same, but now we're pulling from a different file, and the entry point is pushing us into this file right here, workflow number 2. So this workflow number 2 has the lower level implementation of what we're trying to do. And I actually would have grabbed this right from the LangChain documentation. So just right on the home page, there's this high level implementation of like a React system that we were just using, and now I'm switching into this low level implementation. And so I'm going to talk through how this code chunk works, because this is how I built my system using that as a reference. Right. So let me scroll down. We've got a state. I can talk more about this later, but let's see where we use that state. So we have it in here with the should continue, the call model. So this state is automatically being passed into these things, these should continue, these call models. Where's that happening? These are nodes in our graph. So whenever we hit that node, we are sort of having access to this state. Right, let me keep walking through. Print stream is a little helper function. We saw the same thing in the workflow number 1. This is not interesting. It just prints information to the screen. Notice this S messages -1. Like, what's going on here? Well, we're gonna have like this kind of list, right? And it's gonna have this messages, and then inside of messages, that's a list. And so then it's gonna have something like role, right? And the role is like the user or the assistant, and then where is it? It'll be content. Right, like up here, message.content, and the content will be, you know, the stuff coming out, right? Okay, so the reason I'm showing you this is because we should have this kind of picture in our head. I don't know why that's there, of how these messages look. Is this right? Yeah, because there could be multiple or whatever, and so we kind of just want the latest one. That's where that syntax comes from. Okay, so how are we running our workflow? We're gonna define our tools, and these are coming from other libraries. I talked about these in the first video. I will talk about these later, but we have these tools, and then we are creating our own tool node. This is different than the first workflow. We just sort of pass these tools into this create React agent pre-built function, but now we're building the graph ourselves. And so I'm creating an explicit tool node in our graph. For that, again, we're defining our model. Now, just for fun, I want to use a different model. So I'm going to use Anthropic. We're going to get that in, comment out that one. Okay, so now we're using Sonnet. And check this out on the very right, where our binding tools. So we're not just like, we're informing the model about the tools. Now this is really interesting. I'll talk a little bit how this works, like under the hood, what binding tools actually does when we're talking to these models with our agent. because I was curious about that, and I looked into it just a little bit, and it was really interesting when I found out. So this part, we want to define a function. So these are defining like the edges in our graph. We have nodes and edges. So should continue, this is an edge. It's a conditional edge down here. But actually, before talking about that, I want to talk about the function below this, which is call model. And call model is a node right here. So it is our agent. It is our agent node. This is, we're going to be like, we're invoking our model. So this means like we're making I think of invoke as making a call to the API, the model that we're talking to. Of course, it could be like a locally hosted model. Like I've got an Ollama line. We could test this out later. Yeah, sure. I'll test this out later. But it's just very slow. And these hosted models are a lot faster. So I'm using that for the demonstration for now. Okay, so we get a response back from the model, and then we return it in this format. And the way this format's really weird. This takes a lot of getting used to, but because of basically there's a lot going on under the hood. Like even though this is a low-level video, there's a lot going on, inside of LangGraph, so that we have access to do things in this kind of interesting syntax. And what this does is it's going to add this response onto the messages inside of our state. Oh, what? Okay, so let's look at our state up here. It was a type annotated list add messages. So we know that messages is a list, okay? But it kind of has this ability to add messages into the list. I'm not going to explain this well, but I just want you to at least understand why this works. So this add messages comes from LangGraph message, and it affects this object of state in such a way that we are allowed to, where is it? Down here. We don't need to append the response to the previous messages. When we return this, it's going to do some magic in order to add this response as a message onto our messages in our state. Yeah, pretty crazy stuff, right? All right, so I said that this was a node, and I said that we are also the tool node. So if I look for that, we just defined with this tool node, which I imported up here from LangGraph pre-built. So this tool node comes down, and we just define these nodes. And now I have to connect these things, and I do that with edges. So we're going to start with the agent. We import that. Where is it? Oh, that's not it. This is it. So we're importing start, end, and state graph. Of course, do I have end? Okay, end is sort of in this continue. Okay, let's come down. So we come to our agent here. Then we have a conditional node, and this defines like, okay, what do we want to call a tool, or do we want to just like basically restart the chat loop with our agent? If we do call a tool, we always want to go back to the agent. In general, you might not want to do this. Maybe after we call a tool, we want to go to a different part of our graph. But here, we're just always going to return to the agent. And so this should continue step is going to be like determining if we should use our tools or not. And the way we do that is we look at the messages. We look at the latest message. So this would be something that we've just received from like, let's say from Anthropic. And then we're going to say, is that a tool call? So if the last message has tool calls, because Claude will say something like, oh, you want the weather? Well, I have a tool that gets me the live weather. So let's make a tool call to that weather API so that I can get the weather. Then I'll know the weather, and I can tell the user that. So if we're getting a tool call in the message, then we return the tools node, which points to this tools node right here, and we call the tool. And that's how everything was working with the demonstration that I showed before, but now we're just seeing the inner workings of that. So memory saving is really interesting with graphs, but in this case, we're just storing memory inside of like the process, the Python process. So it's just in our computer's memory. When the process dies, the memory dies. So I've actually still got it running over here, but I'm just going to stop it, and the memory is dead. Like I'll never be able to get that context window back. it's done. Here is just how I'm drawing the picture to show you, and we're going to see this because we're going to re-demonstrate this workflow number 2. And then this part is exactly the same as the first notebook. Yeah, I didn't change this at all. All right, I'm just calling graph.stream and I'm sending my inputs through. So exact same thing that was happening before. Right, so I want to demonstrate this. We've switched it to Anthropic. Let's do another quick demonstration. Yeah, everything else is ready to go. So I can just go ahead and run it up here, and we're going to see some logs coming down below. So we can see the graph looks the same. This is what we expected, but this really is the visual that we've been just talking through. There's this dotted line to tools. So we might call tools, but if we do, we will always call back to the agent. And then at some point we might end, but it's important to understand that we have this in a loop. So we're constantly starting and ending. Every time the user is prompted for input, that's because we've ended and we've now restarted it with our Python script. Okay, so they've given us a bunch of ideas. Let's do something. Let's do something in quant finance. Sounds cool to me. And this is why I love these tool calling so much, right? Because it's like a natural interface to calling Python functions. Like I don't need to worry about the specific search term. They've determined the topic for me. The topic is quantitative finance machine learning. Even though I said quant finance sounds cool to me, it like determined a proper topic to research. Okay, so it's actually gone ahead in this case and called a secondary tool. And now it's definitely not happy. Okay, so I'm getting a rate limit error because it's gone ahead and tried to send too many tokens. This is why I stopped using Claude for this, because I kept getting these rate limit errors. I'd probably have to put some sort of delay in here in order to get Claude working for this. But it was interesting because like as soon as it found all those papers, it immediately started downloading these things as PDFs. In fact, it might have, yeah. So it went ahead and called this arXiv API. It got a bunch of data back, and then it's like based on my search results, it found a paper that it was interested in, which triggered the read PDF tool use. It did this all on its own without even asking me. This is why I like human in the loop stuff would be really important. That's what I want to implement next with this, some more human in the loop. And if I come down, yeah, we get our rate limit error, and oops, oh, damn, that's going to make it hard to understand. I just wanted to show you like all the different API calls being made. For example, here's our tool for archive search. You can see the actual, this was the, what is this? What is this? That's the received message. This is the API call for arXiv API right here. Yeah, and then we were like hitting Anthropic with like a bunch of requests, and it was mad about that. Anyway, so nothing we can really do about that, but I could try this Llama grok tool. Let's give that a shot. So I need chat Ollama. This is something up here, and I could go ahead and we don't need Anthropic anymore. Okay, so chat Ollama is, we're gonna use this model Llama 3 grok tool use. I need to make sure Ollama's running. So I'm gonna do that, and there's a, if I just type Ollama, I can see what I have available. And I have a video on the Ollama CLI that you can check out if you're interested in that. So I'm gonna serve with Ollama. This just makes sure Ollama's running on the port that I expect it to be on. Let's go back to over here. So this model also needs to be installed, which it is. So I can check that just back where I'm going to run this code. What was it? Ollama list. Okay, so here's the model, and so I have it available. And yeah, let's give this a shot. So I'm gonna rerun my tool. Chat Ollama is not defined. It should be defined. Pretty sure. Did I not save? I didn't save it. Okay. Okay, let's go back. So this graph is working. That's pretty cool. We've gone ahead and sent off a human message to grok, and you'll notice that this grok that I'm using, it has tool calling available. So okay, so check it out. Now we're making HTTP requests to localhost, and this is where Ollama's running on my computer, and we're using this API chat endpoint in order to talk to this model. That's awesome. Okay, so let's try quant finance again. Okay, quant is a fascinating field. Yeah, let's do risk management. Sure. Great choice. Let's say, actually, no. I want neutrinos. I see, neutrinos. It's no. It thinks someone wants me to do risk management. No, ignore finance. Let's look for neutrino oscillation research in fundamental physics. All right. Okay, great. So that triggered the tool call. This is cool. It's using Ollama, it's running locally, and it's actually responding really fast, a lot faster than I expected. I want to show you, let's go over to a new window, and I'll just show you Ollama PS. And you can see here's like Grok running. It's using a bunch of GPU on my system right now. It's a pretty small model, and so it's got tool use, Grok tool use. So the idea is not every model is going to understand how to serve tools and do things with tool results, but this model does. Happy to help you with that. Ooh, the message is not great here. Pick any paper and get the PDF. Okay, so it looks like this model's sort of hit a limitation too. Maybe I'd have to try and limit the context window if we wanted to get that working, which is too bad. But it was still cool that we were sort of seeing how to talk with Ollama locally. Okay, I wanted to quickly interrupt to talk about my AI engineering roadmap course. I've been developing this website for you, and I've got an update on the course. So these are the actual topics we're going to be covering. And within each of these, let's go to the agents one. I click in here. We've got a couple lessons about agents. So that's the general format. And inside of agent architectures, we're going to have all this information here without having purchased it, and just sort of go through and you can track your progress. I'm still kind of like working through all the little details to make this a really nice learning experience for you. And making sure it's really good content that you're going to get a lot out of. Now, I promised I'd talk about tools and how these tools are working with LangGraph. So here's an example from the documentation. We're going to import this tool decorator, and that will let us define a tool. And here's a tool from the docs about getting weather. And so it's just called search, but I might want to say something like get weather. And then the query, let's call it the city name. And for the city name, what we can do is we can say from typing import literal. And so a literal is going to give us like an option. Let me see if I can get the docs for that. Okay, so literal is we can choose different values. So here's an example, like mode could be read binary, write, or write binary. And it means it's going to be one of those things. So mode would be like a string with one of these options. Okay, so we can use this in a really interesting way with these agents. So let's say, okay, literal down here, and then the city is going to be a literal of, let's say SF works for San Francisco, and let's say New York also works. So now in this case, I can make it a lot simpler. So I can say if city equals SF, right? We'll return the San Francisco weather. And then I'll say else if city, so sorry, LF city equals New York, right? And then we're gonna return sunny. Okay. Oh man. All right, so that's now our function, and call to surf the web. I'm not going to do that. I'm going to say call to get weather data for a city. Just make it really clear what this tool does. And you'll see why this is important with the example I'm about to show you. Of course, this tool, get weather, just to be really explicit about that, we would include that in our list of tools. Just like this, that's all we would need to do. Now our agent would have access to this get weather function that we've just defined up here. So I'll show you my tools in just a second. I did talk about those in the previous video, but I'll sort of walk through those briefly again. But first, I want to wrap this up about how this is working with our model, like more under the hood, like at a lower level. Like, what does this get weather function do? And I was curious about this myself as I was experimenting, and so I discovered some interesting things. So when you bind tools to the language model, for example, using this bind tools, that's exactly what we're doing. If I look for bind tools, do you see down here? We are binding these tools to some sort of model. right? And so when we do that, it becomes available in the prompt context through something called prompt augmentation. So the LangGraph is going to create a prompt that has something like this, and will say, you have access to the following tools, and see get weather, and it's showing this literal so that the language model understands that we can only get weather about New York or San Francisco. And then it also will get the docstring information. And this is what the model understands. It understands it has access to this tool. And then we say something like, when a user asks for weather information, you call this tool with the appropriate city. We know the arguments that it requires. And so this will work with any type of tool, and we'll sort of just list them out in the prompt. And so you might be wondering, does this get repeated for every prompt? How does this remain in the context? That's what I was wondering, at least. So if I scroll down, we'll see an example of that. So here's a conversation. And so we know as we talk to these models, every time we ask a question, we have to include the entire history of the conversation, or at least as much as will fit into the context window, in order to get the next output, the response. So now what's happening is we have information like this exact thing we were just looking at, and this gets included. It's like going to be at the start of the conversation, included as context for every question throughout this interaction. Now this is not literally what the context looks like, and that will also depend on the language model that we're using, but this is like a general, more like a conceptual understanding of what happens, but also actually it probably is fairly accurate. Like these are language models, so this is probably very similar to the actual language that is used in order to describe the tools available to these models. So I thought you'd find that interesting for how these tools are actually working, because I'm always curious about this. So let me show you now my tools. Actually, I just want to get rid of this, all this. We don't need that. And GV, where was it? Okay, let's get rid of this one too. Nice. So my tools are in order: archive search, read PDF, render, LaTeX PDF. These are nothing crazy, but I just have them off in their own files. So if we look at archive search up here, right, I'm importing it from a local file. Archive, it's part of my library. So I can go to that definition and look at this file. And notice my docstring is really clear about how this works. And my topic is a string type. I'm also defining what type we're getting out of this. And by the way, whatever is returned from these tools is like passed directly to the language model for it to do some work on. However, what I would really want to do is have this tool return something that gets added to our state. So that would be an improvement that I want to make. If we look at our state, it looks like this, but I would also want to have something like, I don't know, let's say research papers or something, and this would be a type like that's a dictionary string. I don't know, actually I probably wouldn't want to be that specific. Like let's just say it's a dictionary. Okay, boom. And then I would want to update the state after the tool is called with the result of our tool, which would of course be the result of this, all of these papers, this kind of information, this metadata. What's happening here is very straightforward. I'm just calling an API like this, and I'm parsing the data out. The API is super ghetto, or whatever, but it returns XML, which sucks. So I parse out the JSON. That's all this does. So that's that tool. The other the cool tool is the LaTeX one. I think this renders some LaTeX, so we get some LaTeX content and we actually render that. And I'm actually doing that using this. Where is it? It's like MK LaTeX MK. So it's like it actually starts like a little sub process on our machine, and it'll render this PDF from LaTeX, from a LaTeX string, and save that to our computer, which we saw happening earlier in the video. But again, this is the interesting part for our model. Like this part, to my understanding, this entire docstring and the arguments and the name of the function, these are all used from the language model to understand when it needs to invoke this function. The invocation itself is like not that interesting from an AI perspective. It's just running this on our machine. What's more interesting is how the agent knows when to use this. And that's what we're doing by describing the function and the arguments and the return types and so on. Just to like carry on this example, we could also say, LaTeX document, and it could be like a string, and this could be like the path of the LaTeX document, or better yet, maybe content, and then this is the string of all the content. And so then what we could do is maybe pass this task off to like a different agent or a different node in our graph, and rather than feeding in all of the messages, now maybe we start a new conversation, and we know about this LaTeX content because it's in our state, and so we can start working on that and like building out this research more. Thank you guys for watching, and if you've got this far, I'd appreciate it if you give me a like and consider subscribing if you want to see more topics like this in your home feed on YouTube and learn more about agents and AI engineering in 2025. Now, I want you to keep in mind that what I showed you today, we are calling APIs, which are like there's no token for the arXiv API. That's how I've been getting these research papers and doing these searches. So please be mindful not to spam that, especially like this is a free research service, so we don't want to put pressure on this unnecessarily. Of course, I'm sure they'll ban you if you are hitting it too hard, especially because we're building these kind of autonomous systems where we're not going to be explicitly making these requests ourselves, but we're getting like an agent, something that we don't even control, to go do that. And also the results of this are not intended to be like submitted or used in some sense like spammy kind of research. So as I've been building this project, I've learned how complicated LangGraph is, and these concepts take a lot of work to wrap your head around. So I want to keep developing this tool or something similar at least, and give it more functionality that's going to make it more resilient. For example, we weren't able to use Ollama or Claude because of rate limits. So we need to be able to control these agents a little bit better. I also want to monitor the cost. It's really easy for agents' costs to get out of control. And I want the most important thing I'm thinking about is human in the loop. So I need to be able to control this graph better so that we can say stuff like, do you want to download this PDF before it goes ahead and does that? Or I have more control. Also lots of stuff to build out the state. Like there's so many places we can go to learn more about agents. And I think knowing these tools is going to be crucial, as a language model might say, for AI engineering, to being an AI engineer. It's like it will be a key skill set going into the future. So I'll link these type of videos for you on the screen right now. Thanks again, and namaste.